So I'm Brooke Chan. I was a software engineer on the Dota 2 team here at OpenAI for the past 2 years. So today I'm going to talk a little bit about our project as well as my own personal journey throughout the course of the project. So we're going to actually start at the end. On April 13th, we hosted the OpenAI 5 finals where we beat the TI8 World Champions, OG, at Dota 2 in back-to-back games on stage. So TI stands for the International, which is a major tournament put on by Valve each year with a prize pool upwards of $30 million. You can kind of think of it sort of like the Super Bowl, but for Dota. So there have been previous achievement milestones of superhuman AI in both video games and games in general, such as chess and Go, but this was the first AI to beat the world champions at an esports game. And additionally, as a slightly self-serving update, OG also won the World Championship this year at TI9 just a few weeks ago. So finals wasn't actually our first unveiling. We started the project back in January of 2018, and by June of 2018, we started playing versus human teams. So leading up to finals, we played progressively stronger and stronger teams, both in public and in private. Then most recently, right before finals, we actually lost on stage to a professional team at TI8, which was the tournament that OG later went on to win. So let's go back to the basics for a minute and talk about what is reinforcement learning. So essentially, you can think of it as learning through trial and error. I personally like to compare it to dog training so that I can show off pictures of my dog. So let's say that you want to teach a dog how to sit. You would say sit and just wait for the dog to sit, which is kind of a natural behavior because you're holding a treat up over their head. So they would sit their butt down and then you would give them that treat as a reward. So this is considered capturing the behavior. You're making an association between your command, the action, and the reward. So it's pretty straightforward for simple behaviors like sit, but if you want to teach something more complicated, such as like rolling over, you would essentially be waiting forever because your dog isn't just going to roll over because it doesn't really understand that is something humans enjoy dogs doing. So in order to kind of teach them this, you instead reward progress in the trajectory of the goal behavior. So for example, you reward them for laying down, and then they kind of like lean over a little bit, you reward them for that. And this is considered to be shaping rewards. So you're kind of like teaching them to explore that direction in order to achieve ultimately your goal behavior. So Dota itself is a pretty complicated game. We can't just reward it by purely on winning the game because that would be relatively slow. So we applied this technique of shaped rewards in order to teach the AI to play the game. So we rewarded it for things like gold and kills and objectives, etc. So going more into this, what is Dota? So Dota is a MOBA game, which stands for Multiplayer Online Battle Arena. It's a little bit of a mouthful. It's a game that was developed by Valve, and it has an average of like 500,000 people playing at any given time. It's made up of 2 teams of 5, and they play on opposite sides of the map. And each player controls what's considered a hero who has a unique set of abilities. So everyone starts off equally weak at the beginning of the game, which means that they're low levels and they don't have a lot of gold. And the goal is that over the course of a 30 to 60 minute game, they earn gold and become stronger, and eventually you destroy your opponent's base. So you earn gold and experience across the map through things like small fights or like picking people off, killing your enemy, taking objectives, things like that. Overall, there's a lot of strategy to the game and a lot of different ways to approach it. So why did we pick Dota? So MOBAs in general are considered to be one of the more complex video games, and out of that genre, Dota is considered the most complex. Starting off, the games tend to be pretty lengthy, especially in terms of how RL problems typically are, which means that strategy tends to be hard with a pretty delayed payoff. You might rotate into a particular lane in order to take an objective that you might not be able to take until a minute or a minute and a half later. So it's something that's kind of like hard to associate your actions with the direct rewards that you end up getting from them. Additionally, as opposed to games like Go and chess, Dota has partial information to it, which means that you only get vision around you and your allies. You don't have a full state of the game. You don't know where your enemies are. And this leads to more realistic decision making, similar to our world where you can't like see behind walls. And you can't see like beyond what your actual vision gives you. And then finally, it has both a large action and observation space. It's not necessarily solvable just by considering all the possibilities. There's about 1,000 actions that you can take at any given moment, and the state you're getting back is has a value size of about 20,000. To put it kind of in perspective, on average, your game of chess takes about 40 moves, and Go takes about 150 moves, and Dota is around 20,000 moves. So So that means that the entire duration of a game of chess really wouldn't even get you out of the base in Dota. So this is a graph of our training process. On the left, you have workers that all play the game simultaneously. I know it's not super readable, but it's not really important for this. So each game that they're playing in the top left consists of 2 agents, where an agent is considered like a snapshot of the training. So the rollout workers are dedicated to these games, and the eval workers who are on the bottom left are dedicated to testing games in between these different agents. So all the agents at the beginning of the training start off random. They're basically picking their actions randomly, kind of wandering around the map, doing really awfully, and like not actually getting any reward. The machine in green is what's called the optimizer. So it parses in all of these rollout worker games and kind of like figures out how to update what we call the parameters, which you can kind of consider to be the core of its decision making. It then passes these parameters back into the rollout workers, and that's how you sort of create these continually improving agents. So what we do then is we take all of these agents and we play them against all the other agents in about 15,000 games in order to get a ranking. Each agent gets assigned a true skill, which is basically a score calculated on its win-loss records against all the other agents. So overall, in both training and evaluation, we're really not exposing it to any kind of human play. The upside of this is that we're not influencing the process. We know that they're not just emulating humans, and we're not capping them out at a certain point or like adding a ceiling on it based on the way that humans play. The downside of that is that it's incredibly slow. For the final bot that we had play against OG, we calculated that it had about 45,000 years of training that went into it. Towards the end of training, it was consuming about approximately 250 years of experience per day. All of which we can really do because it's in simulation, and we can do it both asynchronously and sped up. So the first time they do get exposed to human play is during human evaluations. So they don't actually learn during any of these games because we are taking an agent, which is a snapshot and frozen in time, and it's not part of the training process. So we started off playing against our internal team, and our internal team was very much not impressive. So I have us listed as 2K MMR, which is extremely generous. MMR means matchmaking rating, which is a score that Valve assigns to like the ranked play. It's very similar to true skill. 2K is very low. And so we were really quickly surpassed. We then moved on to contract teams who were around like 4K, 6K MMR, and they played each week and were able to give us feedback. And then in the rare opportunities, we got to play against professional teams and players. So overall, our team knew surprisingly little about Dota. I think there are about 4 people on our team who had ever played Dota before, and that's still true post-project, that no one really plays Dota. So this leads us to our very surprising discovery that complicated games are really complicated. And we kind of dug ourselves into this hole. We wanted a really complicated game, and we definitely got one. And since the system was learning in a completely different way than humans, it became really hard to interpret what it was actually trying to do. And not knowing what it was trying to do mean we didn't know if it was doing well, if it was doing poorly, if it was doing the right thing. And this really became a problem that we faced throughout the lifetime of our project. So, diving more into this, there was no way to really ask it what it was thinking. We had metrics and we could surface like stats from our games, but we were always leveraging our own intuition in order to interpret what decisions it was making. On the flip side, we also had human players that we could ask, but it turned out it was sometimes tough to get feedback from human players. Dota itself is a really competitive game, which means that its players are very competitive. We got a lot of feedback immediately following games, which would be very biased or lean negatively. And I can't even count the number of times that like the human team would lose and they'd be like, oh, this bot is terrible. And I'm like, well, if you lost, how is it terrible? Like, what is bad about it? And so this would like create this back and forth that kind of led to this ultimate question of, is it bad or is it just different? Because historically, humans have been the source on how to play this game. They make up the pro scene, they make up the high skill players. They are always the ones that you are going to learn from. So the bots would make a move and the humans say it was different and not how the pros play, and therefore it's bad. So we always had to take the human interpretation with this kind of grain of salt. So I want to elaborate a little bit more about the differences because it goes just beyond the format of how they learn. So this game in general is designed to help humans understand the game. It has like tooltips, ability descriptions, item descriptions, etc. As an example, here's a frozen frame of a hero named Rana, who's the one with the bright green bar in the bottom left. And she has an ability that makes you go invisible. And humans understand what being invisible means. It means people can't see you. On the right is what we see is where we have like what the AI sees, and it's considered their observation space. It's their input from the game. We as engineers and researchers know that this particular value is telling you whether or not you're invisible. So when we hit this ability, you can see that she gets like this little glow to her, which indicates that she's invisible. And people understand that. And the AI uses this ability and sees that the flag that we marked as invisible goes from 0 to 1, but they don't see the label for that, and they don't really even understand what being invisible means. And to be honest, learning invisibility is not something trivial. If like you were walking down the street and all of a sudden you were invisible, it's a little bit hard to tell that anything actually changed. If you've ever seen Sixth Sense, maybe there's some kind of concept there, but additionally, at the same time, all these other numbers around it are also changing due to the fact that there's a lot of things happening on the map at once. So associating that invisibility flag, changing directly to you activating the ability is actually quite difficult. But it's something that's easy for a human to do because you expect it to happen. So not to say that humans have it very easy. The AI has advantages too. The AI doesn't have like human emotions like greed or frustration, and they're always playing at their absolute 100% best. They're also programmatically unselfish, which is something that we did. We created this hyperparameter called Team Spirit, which basically says that you share your rewards with your buddy. So if you get 10 gold or your buddy gets 10 gold, it's totally interchangeable. And theoretically, in a team game, that should be the same case for humans, but inherently it's not. Like people at its core are going to play selfishly. They want to be the carry. They want to be winning the game for the team. So all these things going to influence pretty much every decision and every behavior. So one pretty good example we have of this is called buybacks. So buybacks is a mechanic where when you die in the game, you can pay money in order to immediately come back to life and get back on the map. So when we first enabled the AI to do this, there was a lot of criticism that we got. People were saying, oh, that's really bad. They shouldn't be wasting all their money because the bots would always buy back pretty much immediately. And over time, we continued doing this behavior and people kept saying, oh, that's bad, you should fix it. And we were like, well, that's what they want to do. So eventually, people started seeing it as an advantage to what we had, as an advantage to our play style, because we were able to control the map. We were able to get back there very quickly, and we were able to then force more fights and more objectives from it. And as a second self-serving anecdote, at TI9, there were way more buybacks way earlier. And some people kind of like pointed this out and maybe drew conclusions that it was about us, but I'm not actually personally going to make any statement. But it is one example of the potential to really push this game forward. So this is why it was difficult to have human players give direct feedback on what was broken or why, because they had spent years perfecting this shared understanding of the game that is just like inherently different than what the bots thought. So as one of the few people that played Dota and was like familiar with the game and the scene, in the time leading up to finals, this kind of became my full-time job. I learned to interpret the bot and how it was progressing, and I kind of lived in this layer between the Dota community and ML. And so it became my job to like figure out what was most critical or missing or different about our playstyle, and then how to convert that into changes so that we could shape the behavior of our bot. So naturally, in being in this layer, I also fell into designing and executing all of our events and communication of our research to the public and the Dota community. So in designing our messaging, I had this second unsurprising discovery that understanding our project was a critical piece to being excited about our results. So we could easily say, hey, we taught this bot to learn Dota, and people would say, so what? I learned to play Dota too. What's the big deal? And inherently, it's like the project is hard to explain because in order to understand it and be as excited as we were, you had to get through both the RL layer, which is complicated, and the Dota layer, which is also complicated. So through planning our events, I realized this was something we didn't really have a lot of practice on. This was the first time that we had a lot of eyes on us, belonging to people with not a lot of understanding of reinforcement learning and AI. And they really just wanted to know more. A lot of our content was aimed at people that came in with the context and people that were already in the field. So this led me to take the opportunity to do a rotation for 6 months on the communications team, actually working under Ashley. I wanted to be part of giving people resources to understand our projects. So my responsibilities are now managing upcoming releases and translating our technical results to the public. And so for me, this is a pretty new and big step. I've been an engineer for about 10 years now, and that was kind of like always what I loved doing and what I wanted to do. But experience on this team and growing into a role that didn't really exist at the time allowed me to kind of tackle other sorts of problems. And because that's what we are as engineers at the core, we want to be problem solvers. So that's kind of my takeaway, and it might seem fairly obvious, but sometimes deviating from your path and taking risks let you discover new problems to work on. And they do say that growth tends to be at the inverse of comfort. So that means that the more you push yourself out of your comfort zone and what you're used to, the more you give yourself opportunities for new challenges and discovering new skills. Thank you.